Recording in progress.
Do you have any news about any interview or job offers? Okay. Yeah. Many students are interviewing. They are giving me information, and Kirti got a job. She got. When you got the job, is it like yesterday? It was 2 days back. Okay, nice. Friday. Cool. Congratulations. So which city? Nice. I didn't know they have an office in Boston. I'm not a fan of Chicago, but I like Boston near both. So what I recommend, I mean, if you have time, you might also still apply. You might get another job, and then you can maybe bargain on it. That so. Yeah, actually, I did bargaining even for faculty jobs. Maybe I don't know. Maybe one company you can. The minimum thing that you can get from them, something for housing or a very cool laptop, is the minimum thing, extra thing that you can request. Yeah. Yeah, when you have one offer in your hand, you have a bargaining power for the next. Okay, so please start running your cluster. Hopefully it would get back and get to run. So let's just see what we had. So from a few weeks ago, we started doing machine learning projects in Hadoop ecosystem. So you might remember we start just working with Python, and we had some experience, as I said, how it was difficult just to a simple map reduce. Just assume when you want to do some data management machine learning, it just gets harder and harder. So then instead of doing everything from scratch, we use Hadoop ecosystem. So, and we had some experience with data management through Pig, and then we also look at PySpark, and we have seen that people already made so many packages, so we can incorporate those packages and use PySpark, which is very similar to to Python, and be able to do very advanced projects, even when we have a very large data set. Also, again, if you're interested in working with R, there's a Spark R, which has very similar codes to R, so you can incorporate your R knowledge in a Spark environment. Okay, so having said that, for your final project, you need to have a very sophisticated project, everything from talking about your data processing, like it might include imputation, some basic statistics, and some basic visualizations, which I talk in the next classes. Then we would do model building and evaluating our models. So from previous class, I've shown a very simple logistic regression model, and we didn't like the performance. It was pretty low and also not reliable, because when we changed the random seed, the difference was significant. So what can we do? Just trying different data preparation models, like maybe one hot encoding, another one label encoding. Or maybe you can do feature selection, maybe you can change the models. So today class, we go to we try the loop of model building and the tests and evaluation. So we go back and forth, try different approaches. For your final project, you should at least try 2 different ways. some that could be different algorithms, another one could be different data prep models. I just want to see you tried and you did your best and you try to improve your predictive performance. For the last step, deployment, most likely you can't unless maybe if your project is predicting Bitcoin price, maybe you can deploy your knowledge and just do some trading. But unless, I don't think the last step doesn't seem to be feasible. So if you get a job in a company, maybe in some time in the future, you can go to the last step, which is deployment, and just implement your knowledge for getting some advantages. Any questions? Okay, so let's talk about how you should work with your project. So first of all, you need to know some basics. For example, you have seen that I work on the Spark session and just build everything on top of a session that I started, and also we did some kind of pipelining. There is some basic coding knowledge that you need to have. You don't have to memorize it. If you just do a lot of coding, it will stick in your mind. But just keep in mind, you should know some minimum, some very basic thing. But you don't have to invent the wheel. So you can look at the other people work and look their workflows. Maybe some part of their workflows work for you. You can just adopt them and just add on top of that. Because each project might be unique. Some steps could be same, some steps could be very different. But looking at other people's work is really beneficial. Especially, I think your next step most likely would be either PhD or work in industry. So you can just look at the other people's papers. It doesn't need to be scientific papers, but still you can look at the other people's work, and if you see some good ideas, maybe you can incorporate in your work. So you need to have some kind of updates and also collaborations, especially either way, either you go to research or industry, you need to have some kind of collaboration. So working on the same project with different people. One of the very common tools for collaboration is GitHub. Unfortunately, I don't have time to go over that, but it's pretty easy. And basically, GitHub is nothing just version control. So you guys might work on the same project. Each of you might just focus on some certain parts of a project. And GitHub just lets you to share your codes, and just maybe you follow different versions and just see which version might work better. So if you're a group of 3, you have to have GitHub. If you're a group of 2 or even group of 1, GitHub is a bonus. So you can update your work on the GitHub and provide some comments and just keep working. There is too many tutorials in YouTube or Udemy or LinkedIn, but pretty much easy, not too much difficult. So also you can download some GitHub tool and upload from your own system. So if you work in R you can directly upload from RStudio to GitHub. It's Jupyter Notebook I haven't seen, but you can download some extra tools that you can upload your notebooks. Any questions about your project? Okay, let's talk about missing values that we covered last time. So there's different types of missing value. One could be completely at random. There is no pattern in the missing data. This is the best one. And usually, if there is not a significant, if let's say if less than 90, if up to 90% empty or missing, I recommend to do imputation because we don't want to lose any column or rows and end up having biasness. But the missingness should be completely at random. There's another types of missing values, like missing at random. So some, like, I'm not sure it's a good example, but some, even for males, not certain, not just for females, but let's say a group of people don't want to report. There's a more possibility that one group doesn't report some certain private information, like age. So that could lead to some missingness. But it's not completely at random. There is a pattern. So it could be a gender pattern in it. Other one, missing not at random. So it more likely happens, or more frequently happens in the healthcare. So let's say you are getting patient data, and let's say some type of blood test or hormone test or like enzyme test was not before 2010. So if you put all the patient data from 1990 to 2020, from 1990 to 2010, all of them would be missing, but there was not such a test. Or maybe some tests would be discontinued. So let's say some tests discontinued after 2015. So that values would be missing. So there's a certain reason. So we said missing not at random. So no pattern completely at random. If like a pattern, like a gender pattern, could at random still. But if there is a reason for that, we say not at random. So for the last two cases, we want to get rid of those observations. Maybe your own research, you would say, okay, so for this kind of patient, we just exclude them because we at some certain one point of time, we didn't have those values, and it doesn't make sense to impute them because it was not existing. But if it's completely at random, we intend to do imputation. So just keep in mind, if again, let's say 95% is empty, if it's completely at random, we want to get rid of them, not too many empty. And for dependent variable, we never impute because we want to train a model on the dependent variable. If they're missing there, we just want to get rid of it. Any questions? Again, sorry, I'm not sure what's wrong with the screen today. So one cool algorithm that hopefully if we have time, we cover this week. I'm this week or today, sorry, or maybe next session is feature selection. So for avoiding overfitting, also stacking in a local minimum or local maximum. What I mean local minimum, local maximum. Let's see if you can see. We can see. Okay, so this is actually some operation research concept and usually in under hood of algorithms. But look at two maximum points. One of them is local maximum, another global maximum. So if when you have too many features, let's say you train your model over 100 variables. So the algorithm under hood of your machine learning cannot find the best solution. So the best solution might be maximizing some certain values or minimizing some error. So it might stack in local maximum like here, or stack in a local minimum. Do you guys have had operation research in your undergrad? It's a different type of course, but no worries. So just keep in mind, when you have too many variables, it's sometimes very hard for your algorithm to find the best solution. But local minimum maximum is, you should have another course, but that's fine. It's not necessary. On top of stucking on local minimum, local maximum, or not finding the best solution, sometimes you have overfitting. So the green line on the left figure is for overfitting. So although for your train test, it differentiate the green and blue dots completely, but it's not, you cannot generalize it for any future tests. So for these two reasons, we usually have some feature selection methods to find the best features that first you have a good predictive performance. You don't stuck in the local or maximum point, the local or maximum point, and also you won't face any overfitting. So for those cases, we try to use some feature selection algorithm. Instead of having too many features, we just work with the features that are better. I have a question. Okay, Frank, you had a question?
No.
Oh, you had the course. Okay. Okay, so next, okay, so next few Jupyter notebooks, we try to use different algorithms. We try to do feature selection, also some different data prep to see which one have a better predictive performance. Okay, so please load your logistic regression underline schema underline ECFC. Some part of it repetitive, so you already had in the previous workflow. We import the Spark session and create an app, but here we just have one node, one project. Again, you can exclude this part too. Okay, so in this workflow, I import Titanic.2.csv, and I look at the schema. So passenger the integer, but it might be a string, although it's ID number, but like ID of 2 doesn't, if my ID is 2 and your ID is 4, doesn't mean your ID means 2 times more than me. Just a number, but might be better to be integer. Sorry, a string. For survey, still a string might be better, but although finally you should convert to a number to be able to work with. Passenger class, I think, should be string or categorical variable. So some of them might be changed. So you might remember in one of your workflow, I talked about how to define a schema and just assign it to a data frame so you can have a better variable names. But this schema is just guessed by PySpark. So PySpark thinking that it might be a true schema. Also keep in mind, you should have a data dictionary in your project so I can understand what is going on. For example, Embark is part of the embarkations, Cherbourg, Queenstown, and Southampton. Also, yeah, which one gender, number of siblings, number of parents and children, Embark. Having said that, I try to change the schema based on the one that makes more sense, not what Spark guessed by for itself. For example, let's first of all import a struct field type integer double. So I just import all of them. So later I can assign these characteristics to my variable. So passenger ID string. survived integer, class string, and same for others. So for fail, I sent double because it might have some decimals. Also, age might have some decimals, so I assigned double type. It just means some numerical value that could have some decimal values. Any questions so far? Yeah, so I give you 2 minutes to put some comments if you want. So as you see, I put hashtag, and in front of hashtag, I put some comments. If you want, you can just add for yourself. Okay, so in next block, I'm importing, it's not an efficient way. I just need when, count, and column function. Just keep in mind, sometimes you don't know which function you work with, so you can just import the star. It just means every function in that package. But again, I just used 3 of them. First, I'm doing my own intuitive or personal feature selection. So I don't work with all the variables. So I just picked 8 variables among all of the had. So because for me, some of them doesn't make sense at all to be included. And I'm looking over each column and counting how many null cells I have. So in survive, I have 4. Age is, I have 177 null cells, and also for embarked, 2 cities, I don't have any information. Okay, so do you guys remember the goal of Titanic? Data set. We want to predict if somebody could survive or couldn't. So having said that, and looking at the null values that I have, for embarked, which is the city that they embarked. So what should I do? Should I drop? Should I impute? Or impute, yeah. What about age?
This should drop the no.
Yeah, I should put the next block before, but the next block I'm saying 891. Yeah, sorry. In this next block, I explain how many columns and rows I have. So I have 891 rows. So what about survived column? Yes, because why? Yeah, so for embark, I should just get rid of. So yeah, your friend asked the questions about imputation, and he did it for age. I had 177 empty cells, but he had a good answer. He wanted to be sure. So how many cells I have? If let's say if I have 200 rows and 177 are empty, it doesn't make sense to the imputation. We just should get rid of it. But good question. So with df count, I can find how many rows I have, and with df columns, it gives me the column names, but also with length function, I found the length of that list. So as you see, I have 891 rows and 8 columns. For the statistical column, I can use describe method and just finding some basic statistics about them. For example, age is minimum 0.42, maybe somebody just few months. Number of siblings between 0 and 8, parts 0 to 6, fail 0 to 5, 12. Okay, so we don't do a statistic just for fun. Sometimes we can find some patterns. For example, what does fade of 0 means? Yeah, maybe just a sneak through the shifts. Huh? Maybe they have some specific deal or coupon or who knows, but yes. So when you do descriptive statistics, you should ask such a question. So why somebody had fade of 0? If it's a typo, maybe you change that 0 to, or you impute the 0 with mode or mean of the column. Or age here is fine. See, you might ask question, what does 0.42 means? Maybe somebody was 42 and it was a typo, but we are not sure. But it still makes sense. 0.42 makes sense. So what if the age was -2? Doesn't make sense. So could be a typo in that case. So if you don't have any clue what does negative age means, maybe you have to impute. Here you don't have to. Here 0.42 sounds not that much great, but it still makes sense. For fail, maybe 0 is still questionable, but other than that, the remaining doesn't sound terrible or meaningful. But again, we don't do descriptive statistics for just descriptive statistics. We just is also a part of data prep in case, for example, if here age was negative, definitely there's an issue. Or age of somebody was 800 years, it still could be a typo. So if there is a typo thing, maybe you can look for it. If you find the correct answer, that's fine. Otherwise, we don't want to use some wrong information. If it definitely knows what was the problem, yes, do that. Otherwise, just impute. But still, descriptive statistics is a good way of understanding what is going on and just cleaning your data in the more meaningful way. Okay, so having said that, we want to have 3 imputation, one for embarked, another one for age, and for again survive, we just drop. So age is a numerical value. So maybe we can impute with mean or median. Embark is a city name, so we do imputation with maybe mode. Mode makes sense. Okay, let's see if your friends can see me. Yeah, you guys didn't come to the class, so I'm not sure if you can see the board, but let's see. I guess they can see anything from here. I guess they can see. Yeah. Huh? Yeah, it's okay. I put in this way. Even they can maximize myself. But let's see. I think Kitty did something great. So why I'm seeing Sahan, not myself. Choose. Okay. So I talk about 2 types of imputation. One is label encoding, and the one-hot encoding. So so let's talk about embark. So we just have 3 cities. So one-hot encoding just means for each category you assign a dummy variable. Label encoding, you just assign a number. Okay, so let's first talk about one-hot encoding. So I have three labels or three categories for embark. So instead of this one, which I cannot use it in any machine learning algorithm because characters, just my input for machine learning algorithm should be numeric. So I converted to three dummy columns of S, C, Q. Right? So let's say I have one passenger who embarked in city of, I think, Southampton. Another passenger, P1, P2, embarked in Queensborough, I guess, and the other one Sherburne. So for passenger one who embarked in the city of S, in this three dummy variable, this one should be 1, the remaining is 0. Somebody embarked city of Q, first two are 0, the last one is 1. What about somebody embarked in city of C? 0, 1, 0, 1. This is one-hot encoding. So for label encoding, might this sounds silly, but you assign a number to each category. 1, 2, 3. So it's not a statistical correct, but in this is the flexibility of machine learning algorithm.
Is that in a way that doesn't signify numerical differences, where it's like a hierarchy between the two, where it's like 3 is bigger than 2, 3 is 1?
Yeah, no.
These still factors thing.
So the only goal is converting characters to something that I can import in machine learning. And in machine learning, you don't have the statistical constraint. So it's much more flexible. Still, you can do it. And in this notebook, I think at the end we see that this is a better encoding method in terms of predictive performance. Pardon me? Yeah, sometimes one-hot encoding better. The red one sometimes label encoding. So let's talk about another problem that might be a little above the class, but I think that's important. So let's talk about. Oh. Okay, let's say instead of just 3 cities, I have 9 cities. So first 3 are for England. The second 3, let's say China. And last 3, India. So in one-hot encoding, you assign one dummy variable for each. So A, B, C, K, L, M. So actually, which city are you from? Singapore? Oh, Singapore? Is it in India? Oh, you're from Singapore. Who's from India? So you're which city? Bangalore. So let's Bangalore. So let's convert it to BL. So Singapore, could it? No, it's not. They are not. People are not Chinese there, right? It's very, very multicultural. So let's say China and Singapore. So how to? For my English. So is SIA Singapore. So Singapore. So instead of C, this is SI. SI. So instead of CSI. Okay, so for Ashisha, everything would be 0. Singapore would be 1, 0. For Kirti, everything would be 0, 0, 0, 0, 0, 1, right? Okay. Actually, when you have too many categories, you can do dummy variables, but usually you just ruin your variable. You ruin the variable of embark. When you have too many categories, if you make dummy variable for each category, none of them would be significant. So it's just equal to eliminating that variable. What can you do? Maybe instead of doing dummy variable for each city of a country, maybe for India, you make a 1 dummy variable. For Singapore and China, 1 dummy. For England, another dummy. So E, CS, and I. So for Ashisha, 0, 1, 0. For Kitty, 0, 0. Especially when you go to larger data set, more realistic, you see such a thing. So in those cases, maybe you can make some categories in one group that makes sense. For example, South Asia makes sense to be one category. Southeast Asia, one category. Maybe England, one category. So this is one way. Another one, you can just do simple label, good old label encoding. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Either way is fine. Maybe if you do grouping, is more intuitive maybe for statisticians. If you do show statistics to a statistician, sometimes they freak out. So what? But still in machine learning, you can do that. But grouping also makes a lot of more sense. Any questions? Does it make sense, right? Okay. I think we did this one. Okay, so in previous class, I talked about deep copy and copy in Python or PySpark. Can anyone remember what is deep copy? What is the difference between deep copy and copy?
The copy mode.
Huh?
In deep copy, you cannot change if you're changing something on the deep copy, it doesn't reflect on the original.
Yeah, very correct. So here, let's look at in this block. So in this block, I have already defined my data frame. I converted to pandas because later I want to work with the machine learning algorithm. I have to do the conversion. and I deep copy to missed work, just the arbitrary name. I define my imputer object, and basically here I'm just saying that I want to do median as a statistical imputing on column 3, and I replace it the imputed column with the original column. Let's do the experiment. So also I assign sample to sample copy, and I change column 5 to 1. Let's look at the sample copy. So age is column 5, and everything is 1 here, right? Because I said column 5 should be equal 1. But look at the sample. So sample was just a copy of my data. It's not deep copy. I copied sample to sample copy. When I change a column of sample copy, my sample also changed, because it was not a deep copy. So in those cases, let me. Yeah, previous one I did deep copy, but as an experiment, I wanted to show differences of deep copy and just simple copy. Okay, let's say this is my data. When I just said this one equal to that one, so when I put the comment of sample equal data, and I had a method of 2 pandas. So this name was data. Then I assign name of sample. Your friends can't see. So the name was data, and I assign sample. Yeah. In the next experiment, I said sample equals sample copy. Okay. So then sample copy I log equal 1. What I'm doing, I'm saying sample copy change column 5 to 1. But this is the with affecting data. Also, my sample is just another name of data, so my sample also changed too. So basically, data, sample copy, and sample, all of them are same. I didn't deep copy. So all of them just had different names for one entity. If I change, if I call that entity and changing the column of that, it just means all of them would be changed, because all of them for exactly one location.
But if you change in sample, it will also reflect the data.
Yes, all of them are changed. Sometimes a good practice, sometimes it isn't. Especially for big data, maybe deep copy is not a good idea, because we already have a very large data set. So it really depends. There's no one solution for every cases. But just keep in mind what happens if you just say something equals something. Basically, for one location of data, you're just assigning different names.
I'm thinking like if you use copy and you're doing like machine learning algorithms and stuff, so maybe if you copy, you can do one using one of those deep copy, and then you just do one of those machine learning thing, and then you can use another to change up the values for another.
I see the right thing. Sometimes, maybe in big data, hard drive is much cheaper. Maybe it's better to do deep copy. But in the previous block of the code, if you check, I had deep copy and named the new one as miswork. So when I do deep copy, I just make exactly the same thing somewhere else in my hard drive. So then if I change this data or sample copy or sample, my miswork won't be changed. Any question? So I give you a couple of minutes for you guys to comment. So I had a few blocks for. So in one of them, I did deep copy because later I just want to work with that. Then I had 2 blocks of just equaling some entities to each other. Especially, it's very important when you do a real project. Sometimes you say something equals something, some variable to variable, and you do some changes, and you forget, and then in the later you get a very strange results because you didn't deep copy. You just keep working especially one variable, and just screwed everything. Yeah, give me 1 or 2 minutes so people can put comments. And this is a very common mistake that happens. So one of the times that you get freaking results, maybe you just assign different variable names and you change one of them, suddenly all of them change. So usually for my case, if the data set is not too big, usually I just do deep copy it because I don't want to have those kind of issues. Because when you have like, here we don't have a large data codes, large number of codes, but sometimes when you, let's say you have 200 lines of codes, and sometimes you really don't know what was wrong with your code. Okay, next block, I just did the remaining of imputations. Like I did mode imputing, and also for survive with drop NA method, I just get rid of my missing value in the dependent variable. Then I'm just converted to a Spark data frame and did a looping through that. So I show you the missing values in each column. For your case, if I was in your shoes, what I do, I go to details of the full loop. Maybe you can see what is going on. So you can make some extra block and just check step by step. So the next steps are pretty, I think, similar to previous one. What can I do? What should I do? I define some steps for one-hot encoding and label encoding. Also, I define my pipeline. So having said that, look at the next block. So for my gender, embark, and p class, I'm doing one-hot encoding. So first step, I define a string indexer. So I index each category. Then with one-hot encoding, I can convert them to multiple dummy variables, dummy columns. Same for gender, embark, and p class, because all of them are categorical variables. Again, I put some extra details in the previous session, so you can just look at that notebook. But anyway, so first step, I'm indexing each category of a categorical variable. Then with one-hot encoding, I just make multiple dummy variables. Next block, so I'm just identifying the variables that later I want to import in machine learning model. The way that I do, I just basically define those variables, and with vector assembler, I just basically, again, later, it's just for converting your data in the format is Spark friendly. So you have to have a feature column that has it compacts all of the variables just one column. Then I'm importing two machine learning algorithm, one logistic regression and one random forest classifier. And the last step is just prediction. So basically, I define my prediction object. One is log reg Titanic. So it's just I'm just saying that using feature column and label column survive. Features have all of the columns together, and just using logistic regression for, again, the next one is random forest, feature columns, and the dependent variable or label column is survive. So I already defined some steps for encoding, for modeling, and now I make 3 pipelines here. So look at the first pipeline. Just saying that, okay, get the data, then for gender, embark, and p class, index the categories, then do encoding on each category with assembler one-hot. It just basically compacts all of those columns in just one column. It's not human friendly, just for making Spark friendly. Last step, it used the logistic regression object that we defined before and just make prediction. With LR label, still I'm using logistic regression, but look, I just do indexing. I don't do encoding step, because indexing just means assigning a number to each category or label encoding. So basically, label encoding and one-hot encoding in PySpark is very similar. For one-hot encoding, you have extra step of encoding. For label encoding, just indexing is enough. So you don't have to make dummy columns. Again, with assembler label, you just define your feature columns, and finally you assign your predictive model. And the last one is also I'm doing label encoding and just random forest. So pretty much similar steps, just my predictive object is random forest. Any questions so far? I think the only difficult part is just understanding the differences of label encoding and one-hot encoding. In label encoding, you don't have to use the encode function because indexing is enough. Here, I arbitrarily divide my data in 2 sections, train and test. 80% train, 20% test. And random number is 110. We talked about random seed number in the previous class. Please just look at that. Next block, I'm just basically executing my pipeline. So I'm executing LR one hot, LR label, and RF label. Basically, first one hot encoding logistic regression. Second one, label encoding logistic regression. Last one, label encoding random forest. So I try to look at 3 different ways, see what is the performance. Let me, almost running out of time. So I think some of them I already covered. So next block, I'm just doing the prediction. And so I already trained, with the pipelines, I already trained my model. In the next one, I do prediction and test and train because I want to look at the performance of test and train for both label encoding and one-hot encoding, but just logistic regression. I use random forest later. Then I importing evaluation function, binary classification evaluator and multi-class classification evaluator. So with the binary class classification, you can do AUC. With multi-class classification evaluator, you can find accuracy. Here, I just look at the sample of some predictions. Okay, so here I do my prediction. So I evaluating my both test and train for AUC and accuracy, and also for label encoding and one-hot encoding. After finding AUC of test and train, so in the next block, AUC of my test is 69, train 79. Are you happy with that? Why? Isn't that much high, and there's overfitting because there's a huge difference between train and test. So not happy so far. So let's look at accuracy of one-hot encoding with logistic regression. Still accuracy not great, and it's an obvious overfitting. Let's do label encoding. So with label encoding, AUC, it's still not good, but there's a less overfitting here. For just 4%. And the accuracy, about 3% differences, not very great, but also there is less overfitting, definitely. So far, although label encoding doesn't seem very intuitive, and maybe you just it would freak out some statisticians, but look better here. 77, 87, then overall not big differences, but just less overfitting. So it seems if you do label encoding, is more a reliable model. Any questions so far? I give you 1 minute to put comments, 1 or 2 minutes if you want to add some comments in the blocks. Let's see if there's a question. Okay, one of your friends asked me why I was not happy with one-hot encoding, because the differences between train and test is huge. It's 10% differences. So look at differences of AUC and differences of accuracy. 10% is not a great number. It just seems you don't have a reliable model. But when I did label encoding and look at the performance, it's still not very great, but the difference is about 3-4%. So it seems to be more reliable, less variation. So it was the reason I said label encoding sounds better here. Okay, next step. So we were not that much happy. So what else we can do for improvement in feature selection? So maybe you can run some models. When that model runs, it evaluates the importance of some features. So you can pick the features that are more important. So with getting more important features, it might have two advantages. First, you can improve the performance. Second, you might have less overfitting. Maybe both train and test have a good performance. If you have time, you can look at the next blocks. But just basically, I'm using the random forest. So as you saw, I already had a random forest here, but I never used it. So I use random forest, not for prediction, for identifying importance of the variables. Then I pick the most important ones. Then I use logistic regression for prediction. So this is a roadmap for the next class. Next class, I go over feature selection and show how it works. Also, I mean, we just make our workflow more complex. So as you see, first we just have logistic regression, then we had imputations, then one-hot encoding. Next would be feature selection, cross-validation. So we just try to have a more complex notebook or workflow. So still, I think for you, so I keep working on this until you have good knowledge of your final project. Then if at the end of semester we have more time, I might go back to Hadoop ecosystem and cover more parts. But I think these are more important for your final project, so it's better to teach them first. I also taught you how to do installation over AWS or local system, so you can just play with that too. Still, if you have team of 3, you need to run it in 2 places. One could be local or AWS, and the one Databricks. Any questions? Yeah, we almost ran out of time. Okay, so we keep working on the machine learning Jupyter notebooks. Every time it gets more complex. But also just keep in mind, you need to do your own practice. For example, I mean, usually I do a step-by-step. Sometimes if you forget, go to the previous notebooks. Or sometimes I do for loop or some function, just open it up. You can, let's say, I think I already told you, when you take your mouse between 2 blocks, it brings a plus sign. You can't click on it. And here you can do your own practice. So if you want to just break down the steps, is a really good way of doing that. But don't forget to put comments. Anyway, so if there's no questions, that's for today. Thank you very much. By the way, do I teach too fast or slow? Is it acceptable? In case sometimes if I talk too fast or too, just let me know. I can just modify. Thank you very much. Have the rest of the day.
Thank you very much, Professor.